Hello and welcome. So in this section we are still dealing with the applications of integration, and onto our next application we have volume of solids of revolutions. So we have two types of volumes that are generated. One is when a plane figure which is bounded by the y-axis and the coordinates x rotates about the x-axis through a complete revolution, and the other one is when it rotates about the y-axis through a complete revolution. We're going to handle one example on each, and we are starting with the x-axis. So we have an example here. Find the volume generated when the plane figure bounded by y is equals to 5 cos 2x, the x-axis, and the ordinates at x is equals to 0 and x is equals to pi over 4 rotates about the x-axis through a complete revolution. So this x-axis determines the formula we're going to use. So in this case, our formula will be v, the integral from a to b, pi y squared dx, which will be equals to 0, pi over 4. We're using this, x is 0 and x is pi over 4, pi into, we have our y is 5 cos 2x squared dx. This gives us 0, pi over 4, pi into 25 cos, don't square the coefficient of cos, you're squaring the function. So it becomes cos squared 2x dx. This is our equation number 1. Most of you make that mistake of squaring 2x instead of squaring the function. But now, from trigonometry, we know that cos 2, let's use cos 2x, is equals to 2 cos squared x minus 1, which means that if we make cos squared x the subject, we're going to get cos squared x is equals to a half into 1 plus cos 2x. But now in our case, we have cos squared 2x, so meaning that we still apply the same formula. The only problem is that now everything will double. Not everything really, but we're going to have a half into 1 plus cos 4x. We're just applying this formula. So you see this one here was, so here it's going to get to a half into 1 plus cos 4x. This one is just 4x. So our integral changes to be 0, pi over 4. Now 25 and pi are constants, so we are putting them out. Also, this a half is a constant, so we are saying 25 over 2. So the 25 pi is here. So now we are left with 1 plus cos 4x dx. And if you integrate, you will get 25 over 2 pi into x plus, if you integrate sine cos 4x, you're going to get sine 4x everything over 4. But now this is from 0 to pi over 4. And now you will get 25 over 2 pi into, so if you substitute, pi over 4 will give you pi over 4 minus, okay, we can start with substituting pi over 4 first. So you're going to get, if you substitute pi over 4 everywhere, you're going to get 0 minus, if I substitute 0 here, I'll get a 0, and if I substitute a 0 into the sine function, I'll still get a 0. So this leads me to 25 over 2 pi into pi over 4 minus 0, which is simply 25 over 8 pi squared. And now since it's a volume, the unit become units cube or cubic units. That is if it's rotating about the x-axis. Now, next, for example 2, our question reads that find the volume generated when the plane figure bounded by the curve, the x-axis, and the ordinates is rotated about the y-axis through a complete revolution. So here our solution, our formula will change because one is about the x-axis, the other one is about the y-axis. So we're going to get v from A to B pi, the formula is 2 pi x y dx. So in our case it's from 1 3 2 pi xy. Xy is x into y is x squared plus 5 dx. This is equals to 1 3 2 pi x cubed plus 2 pi 5x dx. But now you can see that 2 pi is a constant, so you're going to factor out that's 2 pi. So after you've factored out the 2 pi, you're going to get 2 pi into x cubed plus 5x dx. And now you integrate, that gives you 2 pi into x power 4 over 4 plus 5x squared over 2. And now our limit is from 1 to 3. So when you substitute, which is quite easy, you will get 2 pi into 20 plus 20, which gives us 80 pi. Our units are units cubic because it is the volume. That's all for this section. Thank you for joining us, and meet you on the next application, which will be the surface area. Thank you. Bye.